All right, guys, let's talk about ionic bonding. Ionic bonding is all about electron transfer, the movement of electrons from one place to another. And a bond is just a very strong attraction for one elemental particle to another. And that's what makes either an ionic bond, which we're going to talk about here in this video, or a different type of bond called a covalent bond. But let's focus first on ionic bonding. So as we know, ionic bonds exist between a metal and a non-metal element. We talked about that when we talked about binary ionic compounds. So these are sort of the things that you need to know, and we'll review these concepts here. Metals ionize by losing electrons. That's what gives them their positive oxidation numbers. Remember the +1, +2, or +3 oxidation states, right? Nonmetals, they're the ones that ionize by gaining electrons, and they end up with the negative oxidation states of -1, -2, or -3. Okay, so if you need help remembering that, go back and see either the ions video or the binary ionic compounds video. Okay, so here's how electron transfer and ionic bonding work. So these are Lewis dot diagrams, and we know what these are at this point. These dots are representing the valence electrons in these neutral atoms. And so sodium has only one valence electron, and that is a very, very, very unhappy sodium atom, right? It wants to get rid of that electron, and chlorine, the same way, is a very, very unhappy atom because it only has 7 valence electrons, where in reality it would like to have 8. And so this is a match made in heaven when these two things come together, because electron transfer just allows the electron that is lost from the metal to be gained by the nonmetal, right? And so basically what happens is that sodium, we know that it wants to lose an electron, and it doesn't lose it to nowhere. It loses it to an atom that wants to gain an electron, like chlorine, right? And so by losing the electron, chlorine is able to fill its valence shell with 8 electrons, and sodium is able to lose its valence shell, which uncovers the second energy level with 8 electrons, and that makes a stable compound. So again, sodium atom loses its lone valence electron, which is gained by the chlorine atom. We represent the electron transfer with this arrow, and the arrow has a pointy end and it's got a blunt end. And the pointy end shows the direction of where the electron is going. So we're going to take the electron and we're going to put an arrow over here to the place where we could put the electron on the chlorine atom. So let's do a few examples of these and show how electron transport works in a couple of other guys. But first, let's talk about why these things stick together once that happens. So when sodium loses its electron, it becomes sodium +1, and chlorine becomes chlorine -1. This is now a chloride ion, right? And this is sodium. And this force called the electrostatic force, this is the attraction between positive and negatively charged particles. And so the sodium ion is very attracted to the chloride ion, and that attraction for the negative from the positive and vice versa, that's a really, really strong attraction. So strong, in fact, that we call it a chemical bond, called an ionic bond. All right, so let's just see what happens when we want to make magnesium oxide. And so the formula for magnesium oxide, Mg with its +2 oxidation state and oxygen with its -2 oxidation state, means that there's no need to cross, and we know that we only have one magnesium ion and an oxide ion in the formula. And we can see this when we start transferring electrons from magnesium into these positions here where we can make a pair of electrons for oxygen. And that, of course, turns the magnesium into its +2 oxidation state and the oxygen into its -2 oxidation state. And now there's a very strong attraction between those two ions, and we make our formula, MgO. Make sense? How about this one? Iron 3 chloride. So as we know, iron type 3, this Roman numeral is representing the oxidation state of iron in this particular ion. So this is Fe plus 3. And that means that iron in its valence level has 3 electrons to lose. And we know that chlorine has a -1 oxidation state. And so we have to do the cross rule to come up with our formula, FeCl3, right? The 3 from the iron becomes the subscript for the chlorine, right? And that tells us that we have one iron atom that's going to donate electrons to 3 different chloride atoms, right? And so we can just draw lines here that show the electron transfer of these 3 individual electrons to these 3 places where they could nest here with the chlorides, right? And that turns these into chloride ions and this into an iron ion. And that's, when we have 1 iron ion and 3 chlorides, that's our formula. Okay, makes sense? All right. So hope that helps.